All right, geometry, it's Mr. Lamb again, and this is page 2 of the review key for transformations. And you'll notice that I have this box up here at the top to remind you that anytime you're trying to find the rule that maps one figure onto the next, I like to use the acronym DIRT, D-R-T, and that is first do your dilation figure, make them the same size. R is get them in the same orientation, either rotate them if they need rotated or reflect them if they need reflected. And then the last one is T, translate, move it to where it needs to be. So what does that mean? So let's take a look at question number 4. It says write the transformation rule that maps the figure to the others. First thing is D, dilation. All right, as I look at these two figures, AB, the segment AB, so I'm trying to get triangle ABC to become triangle, it looks like FGH. Right? Those are the two triangles there that I believe are being mapped from one to the next. So if I'm looking at how long is segment AB, well, it's up 1 and over 2, so 2 squared is 4, 1 squared is 1, so it's radical 5. All right. And FG, it goes down 2 and it goes over 1. So 2 squared is 4 and 1 squared is 1, and it's also radical 5. So in the part of DIRT, dilation, I don't need to dilate these. These things are the same size already. So there is no dilation to do. So now I need to look at orientation. All right. Do I have to rotate this? Do I have to flip this? Which way do I need to go here? And as I look at this, all right, A is on the left side. F is on the left side. All right, B is in the middle, and G is in the middle. And then H and C are both on the right side. So as I'm kind of looking at this on how I can tell which type of R to do, either rotation or reflection, if they're completely messed up, both top and bottom and left to right. So as I look at my colors left to right, in my top triangle, it goes red, green, blue. The bottom goes red, green, blue. That's the same. That means I'm not rotating this. This is a reflection. Right? This is absolutely a reflection. So the first thing I'm going to do is I'm going to reflect this thing. Capital R, I'm going to reflect this. And again, I like to reflect over an axis, so I need to flip it up and down. So I'm going to reflect this across the x-axis. All right, let me draw in the x-axis here. And all right, there's the x-axis. So I'm going to flip all my points to the other side. So I'm actually just going to flip them up here. I'm going to drag them. So right now A is 2 above, so it would go to 2 below. B is 1, 2, 3, 4 above, so it's going 1, 2, 3, 4 below. C is 1 above, so it's going 1 below. Of course, they'd be locked together. All right, so DRT, D, dilation, did not need to dilate them. R, reflect or rotate, I have reflected them. T, translate them, I need to move these things so they're in the right spot. So, looking at my red point, it needs to go to the right, 1, 2, 3, so positive 3, and then it needs to go up 1, so positive 1. So I'm going to do that. I'm going to take them all, right 3, up 1, so my red one, 1, 2, 3, and up 1, it's right where it needs to be. The green one, 1, 2, 3, and up 1, right where it needs to be. The blue one, 1, 2, 3, and up 1, right where it needs to be. So the two transformations, reflect over the x-axis, translate 3, 1. Are there other ways to do it? Absolutely. This is not the only way, but it's the way that I like best. So it's the way that I do it. All right, as I look at B, it's the same thing. I'm looking at little triangle ABC, and I'm going to try to map it to triangle ABC. Looks like it would go then LNM. All right, so L is red, N will go green, M blue. So L and A, N and B, and C. All right, first thing is dirt, DRT, dilation. These are not the same size, so I do have to dilate this thing. I'm going to dilate this thing first, and I need to figure out one of the segments. So the easiest one for me is to look at segment AC. It's 1, 2, 3 units long. That segment would have to be the same as LM, which is 1, 2, 3, 4, 5, 6 units long. And I ask myself, what do I do to 3? So 3 times what has to equal the new one? So ABC, since that's the one I'm starting with, 3 times some value, divide both sides by 3, and you get n to be 2. So the first thing I'm going to do is dilate by a factor of 2. All right, so when I dilate this thing by a factor of 2, I have to take the old points. So I'm going to have to find the old A. So A right now is at, and let me put in these axes again. I just know that this makes it easier when I'm trying to count those points. All right, so the point A is at -2, -2. B is at -1, -1. And C is at 1, -2. All right, so when I dilate these things by a factor of 2, that means -2, 2 becomes -4, 4. Or, I'm sorry, -4, -4. I'm going to go ahead and move that from -2, -2 to -4, -4. And B was at -1, -1. I have to dilate by a factor of 2. Multiply both numbers by 2 makes it -2, -2. And then C is at 1, -2. Multiplying by 2, that's going to give me 2 and -4. That's where they're going to be on the dilation. That's where my A, B, and C are going to move. Remember, A is in red, B is in green, C is in blue. And now I need to DRT. So as I look at my top triangle, it goes red, green, blue from left to right. My bottom one goes red, green, blue. So that means I'm not going to be rotating. That is just going to be a reflection. So I'm going to reflect this thing over the x-axis. That's going to be my second step. So reflect over the x-axis. Okay, now I'm going to flip them all to the top. So the red one right now is 1, 2, 3, 4 below. I'm going to flip it to 4 above, 1, 2, 3, 4 above, and it lands right on point L, which is good for me. It's right where I want it to be. Let's check and make sure the other ones do the same. The green one right now is 2 below. If I flip it 2 above, it's right on M. And the blue one is 4 below. I flip it to 4 above, and it lands right on M. So I don't even need to translate that one. So the first one, they were the same size, and it didn't need a dilation. The last one there, once I reflected them, it did not even take a translation, so I was able to do it in just 2 moves. All right, number 5. In shapes below, if it has line symmetry, sketch the lines of symmetry. If it has rotational symmetry, tell the angle of rotation and the order, and if it has no symmetry, just write none. The first thing I did is I drew a picture of a regular pentagon, and if you did the homework, you know that we came up with a conjecture in the homework that said if it is a regular polygon, the number of sides will give us the number of lines of symmetry. So a regular pentagon has 5 lines, or has 5 sides, so it has 5 lines of symmetry. So where are those lines of symmetry? Well, let's draw them in. They're going to go from the vertex over through the midpoint of the other side. So those are the 5 lines of symmetry. It also has rotational symmetry, and if we think about rotating this red point, I could rotate this 1, 2, 3, 4, 5 different places. So that gives me an order of 5. And if I want to know the degree measure, I just take 360 and divide it by the order, 360 divided by 5 is 72 degrees. So it has line symmetry with 5 lines. It has rotational symmetry at 72 degrees. So every 72 degrees, it would land right back on top of itself again. Letter B there in the middle. As I look for line symmetry, there are none. And if I think about trying to rotate this, there's nothing I can do to rotate this. This thing is not symmetric at all. It has none in the way of symmetries. And letter C out there on the right looks kind of like a waving flag. There are no lines that I can do to cut this thing and make it exactly the same. I was even looking at like some diagonals, but I can rotate this. I can turn this thing upside down one time, so it has an order of 2, which means 360 divided by 2, that would be 180 degrees, rotationally symmetric. So I could rotate it to 180 degrees and get it to where it needs to be. And the last one, question number 6. Question number 6 says, square ABCD is shown, or is transformed to create A prime, B prime, C prime, D prime as shown. Select all the transformations that could have been performed. And we don't know which ones they are, so we're just going to have to kind of pick and choose which ones that it could have been. So if I think about taking this original figure in the upper right there, right, I've highlighted it purple. If I flip that over the line y equals x, then A doesn't change places. Right? 1, 1 still is 1, 1. D, however, 4, 1 becomes 1, 4. It lands on top of B. So it would land on itself, but it would not end up down here. It would not end up in that bottom left quadrant. So this reflection across the y equals x line would not work. Reflection across the line y equals negative 2x, that's even worse. That one doesn't work either. If I rotate this thing 180 degrees clockwise, that means my point 1, 1 becomes the point negative 1, negative 1, which is true. And then B is at 1, 4 would become the point negative 1, negative 4, which is true. C works, D works, this is one of them, this does work. Reflect across the x-axis, then reflect across the y-axis. So if I reflect across the x-axis, A, B, D, and C. And then flip it across the y-axis, you would see that A lands on A, D lands on B, B lands on B, and C lands on C. That one works. Hopefully you know that a reflection across both x and y axes is always the same as 180 degree rotation. And if I were to rotate this thing 270 degrees counterclockwise, all right, here is 1, 2, 270, ends up moving it over here where this is A. Hang on. A is at 1, 1, so it would become for 270. There's my rule for 270. So 1, 1 becomes the point 1, negative 1. So here. For B, the point 1, 4 becomes the point 4, negative 1. There's B. C is at 4, 4. It becomes the point 4, negative 4. And D is the point 4, 1. It becomes the point 1, negative 4. There's D. And then if I were to flip them across the y-axis, A would land on A, but D would land on top of B. And that is what makes this one false. All right? Right, as you think about this, if I were to flip A would flip and land, but B would flip over here to D, and that would be the problem right there. So that's why that last one does not work. That's it for page 2.